All right, good morning. Hope you guys are having a good day. We are going to dive right in to our lesson, which is 8.2.5, completing the square. On Google Classroom, you can either print off a blank copy of this notes page, or you are welcome to use a blank sheet of notebook paper, and I will point out what you need to write and how you need to follow along. So we're going to go ahead and get started and think back to what we did before spring break in chapter 8. It says in lesson 8.2.3, you found that writing the equation of a parabola in graphing form, f of x equals a times x minus h squared plus k, made it easier to find the vertex and the x-intercept. So again, graphing form of a quadratic is what I just highlighted here. F of x equals a times quantity x minus h squared plus k. As a reminder, we were able to look at this form and know exactly what the vertex was. But the question that we didn't address last chapter was, how can we change standard form, ax squared plus bx plus c, into graphing form? In this lesson, we are going to learn a new method called completing the square, and that is how we are going to do so. So if you'd like to title your notes with completing the square, that would be your best option as to how to know kind of the main focus of the day. Let me change my pen width here. Didn't realize it was so thick. And here we go. Our warm-up says use the zero product property to find the exact vertex of y equals x squared plus 8x plus 10. So go ahead and write that equation down. And we want to note that this is in standard form. So when we are in standard form and we are asked to find anything out about this quadratic function, we need to first attempt to factor. And then if we can factor, we then apply what we call ZPP, which utilizes the idea that if we have two factors set equal to 0, then we can use mini equations to solve for those x-intercepts. So again, this is to find those x-intercepts. Now you might say, Ms. Steffen, it asked for the vertex. Well, what do we know about the vertex? We know that the vertex is exactly in between the x-intercepts. So that was where we added the x-intercepts up and divided it by 2, and that gave us that line of symmetry where the vertex was. So if we go ahead and follow along with what they want us to do, we can create our generic rectangle, and we can go ahead and place our x squared, our unit tiles, and create our diamond. Our diamond, we are going to multiply up the diagonal and place that at the top of the mountain. And then we are going to put our x tiles at the bottom of the diamond, and we're going to stop and think, what two numbers multiply to be 10x squared but add to be 8x? We always focus on the multiplication first. So on our factor chart, we know 1 and 10 and 2 and 5 are the only two options that will multiply to be 10. However, 1 plus 10 is not 8 and 2 plus 5 is not 8. So we would say in this case that this is not factorable. So we've run into a roadblock. So there is the motivation behind having to learn a new approach when we are asked to find the vertex, find the x-intercepts, or even sometimes the y-intercept of a quadratic. So here is kind of the bridge that's going to lead us into completing the square. So we are told that the function that we just worked with, what was that? I think it was y equals x squared plus 8x plus 10. Okay, this is standard form. After you complete the square, which we don't yet know what to do, or how to do that, I should say, the graphing form of this same equation, and you want to write this down, is y equals x plus 4 quantity squared minus 6. So knowing that these two things are identical, they're just in different forms, now can we find the x-intercepts? Now, as a review from last chapter, whenever we see x-intercepts, we want to note that y equals 0. So our first step in using this given graphing form that we will be able to come up with here in a few minutes is we are going to replace y with 0, and we are going to go ahead and copy down our graphing form. And now let's review how we can go ahead. Whoops, let me erase that there. How we can go ahead and solve this. Okay, so when we are in graphing form, we cannot use ZPP. We have to use undoing by working outside in. A lot of times I call this reverse PEMDAS. So we are going to go ahead and undo this subtraction with addition. And we see that we now have 6 equals x plus 4 quantity squared. Now at this point, working outside in, we see that there is a square. So how do we undo the square? We want to take the square root. Let's see if I can do a different color. So if we take the square root of both sides, the big thing we learned last chapter was, 1, the square root of 6 is not a perfect square number, and 2, we have to consider the plus or minus case. So please pay close attention to how I'm writing this. At this point, we know that 2 equations or 2 x-intercepts are going to sprout from what we're doing. So at this point, we have what we can also call mini equations when we're working with graphing form, and we can rewrite this as the square root of 6 equals x plus 4, and also negative square root of 6 equals x plus 4. But again, please pay close attention to the negative being outside of the root. So both of these equations are going to be solved in the same way, but we see that the negative outside is going to make them different numbers. So we are going to subtract 4 from both sides, and we see that we get, now we're not going to do 6 minus 4 because we cannot break into the square root. Rather, we are going to write it as negative 4 plus the root of 6 equals x. And then down here in the second case, we have, again, we're subtracting 4, but how is that going to look? It's going to say negative 4 minus the square root of 6 equals x. These are what we call our exact solutions. Okay, but when we go to graph these, remember, we don't know necessarily how to do that in our head because we aren't human calculators necessarily. So we are going to calculate the approximate answer of each of these. So go ahead and pick up your calculator. I'm doing this alongside you. And we are going to type in negative 4 plus the square root of 6. And that should give you negative 1.55 when we round to the nearest hundredth. And then if we go to our second solution, we're going to type in negative 4 minus the square root of 6. And we are going to get approximately negative 6.44. So that'll be, sorry, some of you guys are probably calling me out right now. It should be negative 6.45 because we're going to round that value up for rounding to the nearest hundredth. So these are what we would focus on graphing if the question then said to graph. So again, let me emphasize that those are our x-intercepts. So going back up to the question, it wanted us to find the exact x-intercepts, which we just did. And remember, the exact are here in purple. And then it also wanted us to find the vertex. Now, great news. This is also from last chapter. Remember, the vertex in graphing form is very, very easy. If we go up to our graphing form, okay, remember, we are going to focus on the value that is inside the parentheses with the x and the value that is at the end of the equation by itself. Okay, we are going to look at the value inside the parentheses as the opposite of the x value of the vertex, and then this -6 is the exact y value of the vertex. Okay, this shortcut hopefully is coming back to you. So in this case, the opposite of 4 is -4, and then we're going to tack on that -6 as is. So that is really, really nice when we have graphing form. The vertex takes no extra work. So now finally it says let's make a sketch so that you guys can see it all come full circle. So go ahead and draw in your coordinate plane. Okay, and we are going to need to graph what, sorry, I keep scrolling up, -1.5 and -6.5-ish. So we're really focusing in the negative direction. We can draw a few ticks there. And then go ahead and draw your tick marks on your y-axis as well. So let's make it a little bit thicker. And let's go ahead and plot our vertex for it first. So we're going to go -4 down 6. There's our vertex. And then we're going to go to -1.5-ish on that x-axis and -6.5-ish. Okay, this isn't going to be perfect. And then we can go ahead and we can make our parabola. Actually, that wasn't too bad. Thanks for bearing with me. Okay, so all is great when they give us the vertex form, but we should all be asking, not vertex form, graphing form, how am I going to get standard form into graphing form? So please tune in now to the bulk of the lesson where we are going to learn how to complete the square. After we learn how to do this for the next few days, we are going to be practicing this skill. So it's just as important as when we learned about the factoring with generic rectangle and diamond. So it says, follow along with me. You do not need to copy all of this down. Okay, you're going to copy down when I start a new problem from scratch. It says, Jessica was at home struggling with her algebra homework. She had missed class and did not understand the new method called completing the square. She was supposed to use it to change the standard form. Whoops. Let's get our highlighter to change the standard form into graphing form. Then her precious young sister, who was playing with algebra tiles, said, hey, I bet I know what they mean. Anita's algebra class had been using tiles to multiply and factor binomials. So this standard form, x squared plus 8x plus 10, would look like this. Okay, this is a jumbled pile. You see 1x squared tile, you see 8x rectangles, and 10 unit tiles. From here, Anita continued to say, you need to make a square. Now, square is in bold because we need to review what is so special about a square. Well, most of you guys know that all side lengths are equal. And you probably want to write that down. So a square, all side lengths are equal. So how is a square slightly different from a rectangle? It's different from a rectangle because a rectangle can have different lengths of the base and the height. However, a square has the same length of base and height. So if you look down at the diagrams, you can see here, okay, that this is a square because the length and the width are both x plus 4. But before I get too far ahead of myself, let's continue to read. So the sister is saying, okay, let's go ahead and complete the square. So Jessica arranged the tiles on her mat as shown below. Jessica said, I need 16 small units to fill in the corner. What corner is she talking about? This corner right here. If you notice, Jessica had to place her 1x squared tile in the corner, and then because she had 8x rectangles, to make a perfect square, she had to place an equal number as the length and as the width. So she took the 8x and divided it by 2. And we're going to do this every time we complete the square. So she knew she had to put 4x rectangles on each side. So after that, she created what I'm going to be referring to as kind of the hole that we need to fill. This hole needs to be filled with a certain number of unit tiles. How many unit tiles was she given? She was given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But how do we know how many tiles she needs to fill in that hole? Well, we can see that this hole is a 4 by 4 hole, meaning that when you take 4 times 4, we need a total of 16 units to fill that green area. However, because we have 10, we're thinking about how many more tiles do we need to get to 16? Well, that's a pretty simple math problem for most of us, and we can see that we would need 6 more tiles. So if you look at the next diagram, you can see that she went ahead and she added, we don't want a sticker. She went ahead and added these 6 tiles here, but this is going to take you back to first semester, when we add balance, you can't just add things to one side. What do you have to do? You have to add to the other side of the equation as well. So if you compare the first diagram to the second diagram, you can see that to complete the legal move, she had to add 6 to both sides. Okay, so now you're probably a little overwhelmed, but let's kind of debrief now what she just did. If you recall, we started with the standard form of the equation. And through using our knowledge of algebra tiles, we are able to say that y equals x squared plus 8x plus 10 is equivalent to y plus 6 equals x plus 4 squared. Now, if we go back up to this diagram here, okay, we can see that when she added those 6 tiles on the right-hand side, we call that completing the square. And when you complete the square, that means on the right-hand side, you have a perfect square. So how can we express that algebraically? We can write the same quantity squared, which you can see here on the right-hand side. Now, what do we have on the left-hand side? We cannot forget this plus 6. Now, you might say, why isn't there a plus 6 here? It's because it was utilized to complete the square and make the right-hand side look, what I say, pretty. However, when we deal with a function, the final step is going to be to go ahead and move anything away from the y. So we are going to subtract our 6, and we are going to go ahead and get y equals quantity x plus 4 squared minus 6. And if you look above from the last problem, that is what they said the graphing form was. So you might want to label this as graphing form so that you can connect with instructions on homework or practice problems. Okay, that was a lot to take in. So I'm going to go ahead and skip the final dialogue because, as you guys know, I always get ahead of myself. And I do want to go over one more question before we do a from scratch practice problem. And this is a review from before spring break. It asks, how can you use your graphing calculator to verify that this standard form is truly, sorry, I am really sloppy with this stylus, is truly the same as this graphing form? And some of you guys are saying it right now as we speak. We can go ahead and enter these two functions into our y1 and y2 and check to make sure that it creates the same parabola. Now, if you do not have a graphing calculator these next few weeks, I want you to use Desmos.com. And I'm going to use that as well here in a second. Okay, so we are going to go ahead and go to Desmos.com. I'll take you there as well. And we want to start graphing. Let's see if it's going to want to work with us. Here we go. Okay, and our first function was our standard form. So we are going to type in y equals x, I can use this little squared key, plus 8x plus 10. Okay, so there is the parabola in standard form. And then if you type in the second little section, it'll highlight it. And let's go ahead and put in our graphing form, which was y equals parenthesis, you've got to always use that in graphing form, x plus 4, kind of ignore the line as you go, squared, and then we had minus 6 when we moved that over. Now if you look at my screen here, it looks like one parabola, and that's how we can verify that the standard and graphing form are truly equivalent to the same function. So hopefully you can try that over the next few days and utilize that as a tool to help check your work. Back to our note sheet. Okay, now is the time that is going to help a lot of us really figure out how to do these problems. So on 101, I'd like you to go ahead and write down somewhat of the instructions. The instructions are to write each function in graphing form. So we want to write in graphing form, and then we're going to give the vertex and we're going to give the y-intercept of each parabola. Okay, now go ahead and copy down A. A gives us the standard form, which is x squared plus 6x plus 7. And again, we want to get it into graphing form. So here is a step-by-step of how we're going to do these problems. The first thing that we are going to do is set up a square template. I'm going to call it square template. So f of x is the same thing as y, so we're going to write down our y and leave a little space because we are anticipating having to add balance in a little bit. Now we are going to draw, I'm not going to call it a rectangle, we are going to draw a square, even though it's going to look like your rectangles, because we are completing the square. That is a reminder. Again, we are completing the square. So if you are asked, how do you get a function into graphing form, your response is going to be, we complete the square. So we are going to go ahead, just like factoring, and we're going to place our x squared in the bottom corner. And then always, we now have to think about dividing our x's in half. You always divide them into half when you complete the square. So divide by 2, and we are going to get 3x. So immediately we know that we're going to have 3x rectangles here and 3x rectangles here. It always has to be equal with completing the square. At this point, we now know the dimensions of our perfect square. It's going to be x plus 3, and it's going to be x plus 3. It's always identical on the base and the height. But the problem that you have to think about then is, how many units do we have? Well, we have 7, but how many total do we need? Well, we need 3 times 3 to complete the square, because this box, if I could write, I don't know what's going on here. I think I'm putting my hand on the screen. We have 3 times 3. You always take these numbers and multiply them together. So we have 9. So this is where you have to figure out, okay, what do I need to add? Well, to get from 7 to 9, we are going to add 2. And then we are going to have to also add 2 here to keep it legal. So I'm not always going to have you write add balance, but that will connect you with what we did first semester so you can see it come full circle. So we are going to add balance 2 on each side. So from here then, let's go ahead and write what we now have. So we have y plus 2 equals, we have a perfect square after we added 2 to the right side, so we are going to have x plus 3 quantity squared and nothing else. Now the final step, the easiest step, is to get y by itself, so you're always just going to move your unit that you have to the other side by undoing the operation. So the graphing form is y equals x plus 3 squared minus 2. So this is the answer I'd be looking for if I said put it in graphing form. So go ahead and maybe label that in your notes. But it also wanted now the vertex and the y-intercept. So you should love when graphing form asks you about the vertex. Here's the second time today that we are reviewing that we are going to look at these two numbers and we are going to take the opposite of the number for our x, so -3, and then exactly what we see for our y. So there's the vertex. And then something that we haven't done yet today is that y-intercept. So for the y-intercept, you guys are great about telling me that we need to write x equals 0. So we are going to be careful not to just say the y-intercept is -2 because we are not in standard form. Instead, we are going to replace x with 0 and go ahead and just simply do the calculation with order of operations. So 0 plus 3 is 3. We are going to square that and then subtract 2. So we have 9 minus 2, which is 7. So the y-intercept would be at 0, 7. So I think we've answered everything that they wanted us to answer on this problem. So now what I'm going to do is, this is the honor system, I'm going to have you go ahead and pause the video after you copy down part B, which is just another practice problem, and I want you to try to do exactly what I just did, and then after you've tried, you can unpause the video, and I will take you through all the steps. So again, if you're very uncertain, you can go ahead and keep playing, but if you think you've kind of caught on, or if you think you can follow your notes, now it's your turn to practice with taking x squared plus 4x plus 11 and putting it into graphing form. Okay, so go ahead and pause, and then you can play and see if you got the right answer. All right, here we go. So, because we are completing the square, I'm going to use my square template, where I'm going to do y, leave a space, and then I'm going to draw my square, and immediately I'm going to place my x squared, and then I'm going to place my x's, which is different from a rectangle diamond. I'm going to divide by 2 and see that 2x is going to be placed in each diagonal slot. Now I know the dimensions have to be x plus 2 and x plus 2. So from here, I know that this unit box has to have a total of 4 units. However, I always have to place whatever number of units I'm given in the box originally. Every time what you're given, you have to place inside. But we know our goal is to have only 4. So now we have to think about, how are we going to get from 11 to 4? Now this is a little different from part A. We know that we have to add -7. So sometimes you're going to add negatives, but instead of writing add negative, we know that's the same thing as subtracting. So on this side, if I'm going to add -7, then on this side, I have to add -7 to be fair. So now we're going to go ahead and write what we have, which is y minus 7 equals quantity x plus 2 squared. The final step, hopefully you remembered, is to get y by itself. So we are going to go ahead and add 7 to both sides. And notice I do not add it inside the parentheses due to the squared. So our graphing form is y equals x plus 2 quantity squared plus 7. So this is the first of 3 answers that they wanted. Now from here, we want to go ahead and find the vertex. So the vertex, we are going to take the opposite of inside of the parentheses. So this case, it has to be -2. And then we're going to take exactly what we see on the outside. So the vertex is at x equals -2, y equals 7. And finally, for that y-intercept, again, y-intercept, x has to equal 0. So we're going to set up our equation, y equals 0 plus 2. My 2's are hard to make on here. Squared plus 7. So we have 2 squared is 4 plus 7. And we get, let me scroll down. We get that y equals 11. So this is our y-intercept, and again, we have our vertex. So hopefully you're kind of catching on to that step-by-step process. I was just double checking. We got off the hook on that one. We don't have to sketch the graph. Okay, hang with me. Pause the video if you need to. Do a few jumping jacks to get your blood flowing. And now we are going to do one final problem of the day, which, oops, I forgot to erase. So I am going to go ahead and erase really quickly here. Actually, I think I remember I can highlight everything and I can press delete. Let me scroll down a little bit more. Highlight, delete. And we'll just do some erasing from this point on. Okay. One final problem of the day. So I'm going to scroll back up. Whoops, undo. Here we go. So it says Jessica needs to complete the square to write the standard form in graphing form. So again, completing the square is how we rewrite something in graphing form. Draw tiles to help her figure out how to make this expression into a square. Does she have too few or too many? Well, we just learned the process of completing the square, so let's go ahead and complete the square. So we see that we're going to have y equals, and again, pause it and try this on your own, and then play back if you need to. We have y, leave a space, equals. We have x squared, and now we have to take our 4x divided by 2, so we have 2 x's are going to go in each diagonal. So we now know our perfect square form is, again, going to be x plus 2, x plus 2. And we see that we have currently 9, but again, we only want 2 times 2, which is 4. So we have to think about how do we get from 9 to 4. So at this point, we are going to go ahead and think that, oh, we have to subtract 5 from 9. So if we're going to do that on one side, we have to do that on the other side. So now we have the graphing form of or not graphing form yet, but we have y minus 5 equals x plus 2 quantity squared. And then from there, if we go ahead and add 5 to each side, we have y equals x plus 2 squared plus 5. So this is our graphing form. So now it asks us to go ahead and find the vertex and the x-intercepts. And let's start with that easy vertex. So what are we going to do? We're going to take the opposite of 2, which is -2, and exactly what we see as our units. So there's our vertex. And then x-intercepts. For x-intercepts, we know that y is always 0. We did this in the beginning of the lesson. So we have 0 equals x plus 2 squared plus 5. So to solve this, we solve by undoing, working outside in. So if we go ahead and subtract 5 from each side, we get -5 equals x plus 2 quantity squared. Now, we notice, okay, that next to undo the square, we take the square root, but a red flag should go up because, you should be saying it with me, we cannot square root a negative. So unlike when we used ZPP and thought, maybe there are still x-intercepts, when we complete the square, if you run into this roadblock, we know that that means no x-intercepts. So go ahead and write yourself that note. There are no x-intercepts. So that means our parabola is either all the way above or all the way below the x-axis and will never cross it. So in this case, right now, we only have 1 point to graph. And what is that point? That point is -2, 5. So we need at least 2 more points in order to create an accurate parabola. So at this point, we need to go ahead and rely on that y-intercept. So to get the y-intercept, you guys should be, again, saying it with me. We know that x equals 0. So we're going to say y equals 0 plus 2 squared plus 5. And we're just going to do the order of operations. And we have 2 squared, I'll just write it, plus 5. So y equals 4 plus 5. Our y-intercept is 9. So that's only a second point. But what can we do? We can mirror this point over the line of symmetry. So let's go ahead and complete our graph. I'm going to zoom in a little bit. So we have -2, 5. So our vertex is at -2, 5. Okay, and we can draw in our line of symmetry if that helps some of you, because knowing our vertex, there is our line of symmetry. And then we know that the y-intercept is 9. And then from there, we can go ahead and mirror image that y-intercept by counting and seeing that it's 2 away from the line of symmetry. So then we're going to count 2 in the other direction, and there we go. So this is going to be a very skinny parabola. And what am I thinking here? We said that there are no x-intercepts, but yet I see that my parabola is going to cross the x-axis. So I'm going to go up and see that I graphed the vertex wrong. Sorry if you followed along with me. I see that I need to go -2 in the x direction, but I need to go up 5, so I don't know what I was thinking there. So we are going to get out our eraser and start over real quick. This won't take too long. Let's go -2, 5. That looks much better. We have our line of symmetry. And then we can go ahead and graph our 9 and then count 2 spaces in and then 2 spaces over. And here is the parabola, and that looks much better because it matches the observation that we should not have any x-intercepts. So that is the completion of our notes today. Thanks for hanging with me. Please see Google Classroom for what your assignment is and make sure you are following along there. And over the next few days, we will get more and more practice with this idea of changing standard form of a quadratic into graphing form of a quadratic by using the method that we call completing the square.